thank you for showing up. Today, first I will, okay, the recording is a good way to exchange about the things I'm working on, the things we've been doing on the Haxe compiler, some of the features that are maybe not so much known in the community, but very powerful of their use. So if you want to learn more about Haxe, please come up to this streaming or show the recording, see the recording. Today, okay, first I will make a bit of news. Today we have some news about the new blog on Haxe.org. Maybe you saw that already. I will just put the URL in the chat now. Haxe.org/blog. I will show you here. So this is a new blog we've been working on for some time. So you have different articles. We have an article about Haxe Develop, which was announced last week, which is a new IDE based on Flash Develop, but dedicated to Haxe development. So you can see a full post about how we came to develop that. And we have also a post about Haxe Foundation, which is a post I wrote a few months ago. So it's been already published. It's now republished on the blog, so people can find it about the reports, the work we've been doing, and what kind of organizations improvement we are planning to do. And there's also a very interesting post on TiVo, which is one of the member of Haxe Foundation partner, which supports Haxe development, explaining what the kind of work they made with Haxe and how they bring 1 million lines of code to from Flash to Haxe, and how they are basically very happy with it. So you have a lot of feedback from. So if you're interested in this, in this case, please read the blog, and we'll try to post more things. We have more news to announce or more different things to showcase. Okay, I will switch to this. Or maybe I can do this. I can put maybe the camera. Where is the camera? I can put it up. Okay. Oh, I'm just learning to do some proper streaming, so please bear with my glitch. Okay. So we'll get started today with something new. So I will open Haxe Develop. And today's topic will be about how to improve your compilation time. So the first interesting things is to be able to measure accurately your compilation time. If you have, as you know, Haxe compile is very fast. You can have pretty large projects without having to do anything in terms of optimization of compilation time. But when you grow into quite large projects, maybe sometimes you want to be able to compile faster, or to improve your completion speed, for instance, which is compiler based. So we get started to show you first how you actually display the times of compilation. So here just a small empty example. So if I go in compiler options in my properties, I can use dash times. This will allow me to, when I compile, to get in the output of my in the output. So it doesn't show in the results. It's not an error. It's just output. You get this kind of results. Okay, saying okay, this is a total time of compilation. It's 1 second, and then you have a breakdown of the different things that are being made on this time. So you say like here we spend 17 milliseconds or 2% at parsing 4% at typing, and most of our time in filters, which is something which is done before compilation. And if you look, the first compilation was 1 second, and the other compilation are like less than 100 milliseconds. This is because I have activated in my options the compiler cache. So I will disable it now. We will work first without compiler cache, and we will see after how it can improve things in very major things. So let me check. In program settings, compiler. No, this is completion maybe. Yeah. Oh, now we are on completion server. Okay, we are still on the compiler. Okay, we don't have a compiler cache activated. Sorry, it was just because of the first run was taking some time because of maybe the way to start. So you can see here a very small example. It compiles very fast. Now I will try to switch with something a bit bigger. Which is, for instance, this. Okay. Yeah, it's trying to open with Flash Develop, that's why. Okay. Now we open this here. No. Open with Xdevelop. Yeah, that's what I wanted to do. Okay. Here you can see it takes a bit more time to compile. A few seconds, not that much, but still you can feel it. So if I add the dash times, I can see a breakdown saying, okay, this took 4.7 seconds to compile, and the time is spent mostly, you see, macro execution, which is very interesting here because we have 50% of our time spent in macro execution, and here you have filters, parsing and typing, writing the Swift, because this is compiling to Flash, but if you compile into another platforms, writing to JavaScript, you will see like the output, the filter. So you have a lot of breakdown of where the time is spent in compilation. So here, if I compile several times, you will see I will always have actually the same amount of time. So let's try to see how you actually compile with a compilation server. So first, we will try to. So I open here, open a console, projects, samples, basic. So here I can do the same thing, saying, okay, X, what is this called? Basic underscore Swift. And if I use dash times, you get the same compilation, and then after you get the result, which is 5.5 seconds, 4.5 seconds. So here I will start two sessions, two command line. The first one will be our compilation server. So when you are in the IDE, you have some options maybe to enable compilation server. When you are not, you can create one by command line using x -- wait, and then you put the port, for instance, port 6000, and here the compilation server start listening on port 6000. So it's not accessible outside of your computer; it's on your local computer. So there's no security risk here. And if I here my compilation, instead of running it locally, I will ask it to connect on the compilation server. So I will use -- connect 5000, and then I put the compilation parameters. So here they are stored in my HXML file, and I'm doing also -- times to check how much time. So the first run, it will be pretty much the same, because it compiles, it sends a command from the here to the compilation server that will perform the compilation and return. So, but if I compile a second time, you will see that since we have changed almost nothing in our project, you see that we have only half a second of compilation instead of the 4.6 seconds before. So we have basically speed up our compilation by factor of 10, which is very interesting if you have significant project size. So the writing the Swift and generating it still takes half of the time, and we have this new thing showing up that was not showing before, which is a module cache check, which is basically the cost to check that the compilation server has not actually identified, nothing has been changed on the hard drive. So if you, for instance, if I change this file, so I just open it and save it again, and I restart the compilation. Now you see it's still pretty fast. It's a bit slower than nothing changed. And actually we can get, if I stop the compilation server and I start it with -v, which is a verbose mode, you can check, you can see what's happening on the compilation server. So here you can say, if I use -v, say it's waiting on my local IP address on the port 6000. So when I start the first time, we see it will say it parse all these files, and in the end it will say, okay, I have cached 600 modules and I cache already 150 modules. A module is a HX file basically. And then you have some statistic. We have parsed 700 files, 580 classes, 5,000 methods and 45 macros, and we spent 5.7 seconds, which is a bit more because we had a lot of trace. So if I just return one more time, you say it prints all the thing is being, it's a reusing for each module, and in the end you see it has 0 file, 0 class, 0 methods, and 1 macros. So 1 macros because this is a macro we have as part of our compilation parameter, so it's only always run. So you see here is a very big difference. And if I change the main file, the main.hx file, and I compile again, you will see that it's reusing a lot of things, and then it says that main hashix has been modified, so it will be skipping the cached module, parse it again, and then you see in the end we have 1 file and 6 classes and 3 methods and 3 macros which has run again. So it will only recompile the minimal amount it has to compile. One thing to understand is that the whole caching depends also on your compilation parameters. So for instance, if I had the -debug to the compilation parameters, it will be another context, because this is the same code but compiled with different defines. Because when you use this -debug, maybe some code use if debug at some place, so we need to recompile the whole code. But it will have so we here recompile the whole code, but it will have its own cache, which is separated. So if I recompile the debug, here it's very fast. And now if I go back and compile again the not debug, again it's reusing. So you have 2 versions of the code into the compiler cache. Now we have a version with debug and a version without debug. And if you have different compilation options, it will be kept this way. So I think this is quite important to have these features in compilation. So I will check the chat quickly. Okay, seems okay because I don't see any complaint on the chat. Okay, so now how do if you put in place in your project the compilation server, I think it gives you a very big optimization. Sometimes with macros you can actually, there is a few features that will disable the cache, because in particular the macros in macros, which is something very might happen sometimes even if you don't exactly accept it. So one way to debug that is to use a compilation server in a verbose mode, like I did just right now. So you can see when you run another compilation if the reusing is correctly being done. So if you see in the end you have a statistic with no files, no class, no methods, and it's just printing a lot of reusing, then it means that the compiler cache is correctly working here. And if it's not, you will get a lot of things going on. We have improved quite a few things, in particular with IDE support. So if you're using a recent IDE version of Xdevelop or Flash Develop, I think you should be using together the JIT version, the dev version of Haxe compiler, to make sure that the compilation cache is actually quite well optimized. And of course, it will be in the next release of Haxe in 3.3. We will have everything correctly set up. One of the things I want to show you is how to understand all the time is spent in macro code. Because when you have a lot of macros, sometimes it's hard to know which macro is slowing you down. So we have another, so I will stop using compiler cache for now and just show you here. If I use -- times, as you can see here, on a normal compilation, 51% of my time is spent on macro execution. So of course, the files that actually run the macros, if they are stored in the compiler cache, you don't really need to run the macros again. So it means that you don't get this cost of for execution. But if I still want to know what time, how the time is spent, I can use a specific define, which is -d macro times, macro - times. And when I compile with macro times, I will get the same output, but instead of having one single time for all the macros, I will get one time per method. So I can see here that these different macros takes almost no time, and what takes a lot of time is the 2 seconds are taken by HXL macros build shader, which takes most of the time of the macro, and 7% of the time is actually taken by the typing and initialization of macros. So it's mostly time spent executing this method, which is time spent in macros. So, well, that can be useful if you want to optimize your macros or actually get something to know about your macros. One other thing I wanted to show you is how using compilation server actually affects your completion time, because maybe you don't care about having saving 1 or 2 seconds per compilation, but when it comes to completion, it's very nice to be able to have a immediate completion. So when you have a -- times included in your project's options, if you use completion, this is interesting, you also get, so you will see there is two completion of Flash develop. There is a first completion that show up is a completion that Flash develop guess, and the second one that show up is the one that is sent by the Haxe compiler, which might be able to infer a few things. For instance, if I have an array here and I push into some custom class here, and I do this, okay, you will see that you have some time before the completion because Flash develop and the IDE is not able to infer the type of this array as containing objects of this kind. So when you press a dot, you will have to call the compiler to wait the compiler answer of the inference analysis to be able to display the completion with the actual method names. So this is correspond to in Haxe develop to it's in the program settings. You have in the Haxe, it's in completion Haxe context. This completion mode is compiler, so it's using and here I can set completion to completion server, which will be used a compilation server actually for both completion and compilation, and you can see the port by default is 6000. So when you do that, first if I compile my first compilation, so you see here in the command line it's saying it's connected on 6000 port 6000. So the first compilation takes 4 seconds, and the other compilation just takes less than 1 second. And more than that, my completion now is very fast. It's almost instant because I'm using. You can see it's you get completion is less than 100 milliseconds because we have we are using completion server as well. So I think this is very important to have fast completion and fast compilation when you're running your projects, and using the completion server and compilation server I think is really really useful for that. So what I wanted else to say, I think that's pretty much all about the compilation server. So yeah, we know there is maybe still a few open issues that we are investigating about the compilation server. So we will be really interested in getting your feedback. So if you could try running your compilation using on your project using the compilation server, and then you can report any issue you might have on X-Foundation/Haxe uses regarding things that are not working well with the compilation server, then we will be able to improve it much more, eventually fix a few bugs that we might have to improve the quality and the speed of the compilation server. Yep. Okay, I know I need to change that for the next time. That's all. Thank you. Is there any questions? I will wait a bit on the chat. So Dan would like some tips about how to write cache-friendly macros. Well, the first thing is to never use macros in macros because it entirely basically disable the compilation cache for these macros and all the class that use it. Yeah, and Simon asked about static variables in macros. Right now, the thing we have is that we have a cache. When your compiler cache is activated, you have a cache of your whole macros context, which is a bit like an application which is running and we are calling the macro methods when they need to be called. So it means that, for instance, your statics variables, they will still be kept between compilations. They will not be reset to the default between compilations. So you can use that to actually have some kind of state between compilations and be able to cache a few results if you don't want them to be done every time. So I think that answers both Simon and Dan's question. This is a way to, if you use it smartly, this is a way to prevent rebuilding or a lot of things in your macros and have actually make a good use of the compilation server. Also for caching not only the macro context but also the macro results, even if they have to be run one more time. And here we will publish this record maybe on the blog when it's as soon as possible. Well, I think that's all for today. I will make another session next week. I hope it went better than last time on the technical side. And thank you for showing up. Bye-bye.